Okay, so we want to write this one in vertex form so that we can hopefully just snag the vertex out of that easily. I will say that that's definitely not the most efficient way. The easiest way to find the vertex from this form, from standard form, the most efficient way would be to hopefully remember the negative b over 2a formula. Um, but there are other really good reasons to want to be able to write something in vertex form. And there are other really good reasons to want to complete the square, which is what we'll have to do to write this in vertex form. So we're just going to keep that complete the square practice going right here and use it as another way to look for the vertex of something that's in standard form. Okay, so if we're going to complete the square, we basically want to take this 2x squared minus 6x plus 1 and try and build a perfect square in there. We don't care if there's an extra constant at the end, but this 2x squared minus 6x, we definitely want a perfect square out of that. So let's sort of mentally separate that off. Here, we're looking at this and say, okay, we want to complete the square on those two terms. We're just going to ignore the 1 for now. So let's start by factoring out a 2. I will say that now that we have an equal sign in the mix, there are actually other ways to rearrange this to complete the square. So if you've learned a little bit different tricks where you move things over with the p of x, there's nothing wrong with those. I've just found that since we've just done completing the square on an expression, if I mix it up a little bit right now and make it look a little different, it just throws everyone off. So I'm just going to make it look very much the same as what we did there, but there are some little options to make things look slightly different that sometimes people like. So feel free to look for them, ask me about them. If you already know them, use them. Otherwise, just like before, we factor the 2 out. And now we're looking for numbers that add up to negative 3. Okay, well, I don't even think I want to say it that way. We're looking for the perfect number to make this perfect square. So we're going to take that negative 3, we're going to cut it in half, we're going to square it, and we get 9/4. And there's a little bit of magic happening there, but hopefully it's starting to make sense to you why we do that magic. Otherwise, that is one that you have to remember. So there's a little memorization piece, which I try and avoid, but we're stuck with it here. Okay, so we're going to add that in. And then we don't want to change the value of what we're working with, so we also need to subtract it off. But we have to be really, really careful because technically we didn't just add in 9/4, we added in 2 times 9/4. So we're going to subtract 2 times 9/4 as well, which that actually works out kind of nicely. If we make that 2 over 1, we can cancel a 2, and we really have 9/2. Okay, so in the parentheses, we're hopefully ready to factor now. We're looking for numbers, and it should be 2 of the same number really, that will add up to negative 3 and multiply to 9/4. And it starts to sound a little tricky when there's fractions in the mix, but we've actually already found that number. We built this on purpose. That negative 3/2, if you add negative 3/2 to itself, you get negative 3. And if you multiply negative 3/2 by itself, you get 9/4. We specifically built that 9/4 so that this would be true. So we need x minus 3/2 times x minus 3/2 to make that factor, and that is in fact a perfect square. And then all we have left is just to deal with the mess that didn't quite fit into our perfect square. So I have 1 minus 9/2. 1 is the same as 2/2. So 2/2 minus 9/2 is negative 7/2. And there's my vertex form. At first, using complete the square seems really rough, but if you just give this trick a try and do it a little bit, it's really pretty quick. It's a couple of steps and you're done. So don't write it off, even though it feels a little messy at first, I know, and it feels a little like you're just doing some magic and not really knowing what's going on with it. Last thing for now is we should be able to look at this and state the vertex of our parabola. So again, if we're thinking about vertex form, we're comparing H and K. So again here, remember when you do this, the x-coordinate of your vertex, it does have a funny sign swap that happens. So if it's x minus 3/2, the x value is actually positive 3/2. And later when we look at this as shifting graphs, what's happening there is when you subtract 3/2 from your x, kind of counterintuitively, it actually shifts everything to the right 3/2. And then for y's, there is no sign swap, so that really will be -7/2 as the y value of my vertex. And as we get into moving graphs around, that would be a shift down 7/2 that's actually making the vertex move down there. So again, we're not quite there yet, but just to think about what this means graphically, we're going over 1.5, down 3.5 to find the vertex. And then because this was a +2 out in front, we know we have a parabola that opens up. So we don't really have an idea yet. We haven't talked a lot about this, about how skinny or wide it is. But that 2 makes me think it's a little on the skinny side. So maybe something kind of like this. A very rough sketch, but that's what we're going for in the long run. Okay, thanks for watching.